Hey, today I want to continue with the AI. Uh, I'm going to focus on making a character that will uh, follow us, run from us, and when at an appropriate distance, uh, in the simple case here, jump, but later we'll add an attack to that uh, vital animation. So let me get the screen going here. So chasing AI, um, we're gonna do this. We're gonna have three states. We're gonna have the idle state, the chase state, and then what it does when it catches its target. I'll call it the jump state. And we're gonna have various transitions among the states. If we're idling and we can see the target, we'll chase it. If we're at the appropriate distance to jump, we'll transition to the jump state. And of course, out of each of these states, we'll have can't jumps and can't sees that go back to chasing or go back to idling. Our logic for this is fairly simple. If we can see, then we have two choices. We can either jump if we can jump, or if we can't jump, we will chase. And if we can't see, then we'll idle. So the logic of this state diagram is pretty succinct, pretty precise here. So I'm going to make a bunch of little functions that test the different Booleans that I'm going to have in here, the can see, can jump, and so forth. And so a Boolean function that's going to determine whether we can see our character, our player, is the can see function, returning a Boolean. It forms a vector between the AI's position, the transform position, and the target position. Calculates that distance with a dot magnitude. And then if the distance is greater than the C distance, if we're too far away, then it's going to return a false. In other words, we can't see. If it's less than the C distance, then we'll return a true, and we can see. I might add a field of view concept to our can see function by forming an angle, a vector3 dot angle between the direction to the target and our transform forward, our AI's forward direction, and add to my test if we're greater than the C distance, or if the angle is greater than some field of view sight angle that we can see, return a false. Otherwise, of course, return a true. So this way, our AI has to actually be facing towards the target in order to be able to see it. The can jump function is pretty similar. We form a distance between the transform position and the transform target, this time using the vector3 distance function. And if distance is greater than the jump distance, then we can't jump, so we return a false, and otherwise we return a true. So we have these simple functions that will be used in our logic. So some details of our AI script. We've got various exposed variables that we can set. We have a C distance, we have a jump distance, we have a rotation speed, how fast you'll turn. I have a state variable here that is just going to display what the state my character's in. I'll set this in the different components. And I have current distance, sight angle. I also am including a transform for the eyes, since our characters, their root position is all at their feet. I wanted all this sight stuff to be going on at a height that is comparable to the character's head. So I've got something called the eyes that I can position at the head of my character. And so private variables, there's going to be an animator that we need to catch. I've got two Booleans, can see and can't jump, that are both initially false. I have two damping times that are going to be used to moderate how quickly the states in our mechanism transition, and a direction. So in the start function, the first thing I'll do is cache a copy of the animator, animator get component animator, and I'll enter the idle state. The update function is where all our logic's going to be. So I'm casting a current distance. I'm calling the can jump and can't see functions with their return values into the Boolean can jump and can't see. And I'm setting the can see and can't jump parameters in my animator. And then here's that logic that I showed you before. Can see, can jump, jump, otherwise chase, otherwise will idle. Our controller looks like this. We've got an idle function, a chase, and a jump with various transitions among them. We have the parameters can see and can jump, and we've got our speed and direction that are going to be used to control the chasing. I'll look at these in a second. For the idle state, I found an animation from that raw mocaps file that I pointed you to called idle turn right 45 that was trimmed down from a larger raw animation, idle neutral 245, idle to neutral idle. And it was a fair amount of fiddling to get it trimmed. One thing that's really nice about the modern animations that have root motion is that you don't actually have to turn the character yourself or move the character forward yourself. The animation does all that for you. The chase state is a blend tree, similar to what we used when we were building our controllable character. It's controlled by the parameter direction. That's going to tell you whether to turn to the right or to the left. And again, there are three animations that I got from raw mocaps: walk forward, turn left, walk forward, and turn right wide. And all of these were appropriately trimmed down to make them loop nicely and to be in sync with each other. And I must admit there was a considerable amount of fiddling in working with these raw mocaps, because they're, I'll show you in a second here. The jump state, also from raw mocaps, is an aborted jump, jumping to, I misspelled it, with idle cannot up idle, from idle cannot up idle. And of course the transitions are very simple. Idle to and from chase based on can see, chase to and from jump based on can jump, and direction controlling the amount of turning. Again, thank you, root motion. And even though speed is there, it appears I'm not actually using speed for anything in here, since our character's motion is being controlled by the can see, can't jump, and so forth. So let's look at that. Here's that controller. Well, first let me run this so we can see it. Here's my little character out here standing in the world. I'm in a first person character. So he follows me. Let me turn on gizmos here and maximize. So I've got a little gizmo that draws a line from his eyes there. if I'm far away, he follows me. And I have this little wall over here that ultimately I would like to be able to hide behind. But at this point, that doesn't happen. You can see here I'm outside his C distance, so even though he's scanning for me, he can't see me until I move a little closer, and now he can see me, and oops, I went outside the distance. I'm going to fix this feature later so that he doesn't see me when I'm behind the target.